Hi, Amy.
Hi,
How are
Seth.
you?
I'm
How's it
good, thank
going?
you. How are you?
Very good, very good.
Yeah, going okay.
Yeah,
Got online school for
that's very good.
until February. So
Oh my
yeah,
God. Until February. Okay. That's good. So hopefully the situation will improve by then.
hopefully.
The second wave
It's
of
not
COVID.
looking good though.
Yeah.
Yeah,
The
it's
other
going.
strain of COVID is also picking up or it is under control now in UK.
It's picking up.
Oh my God.
It's not really in control. Yeah, it's not
Okay.
good.
Let's
You
hope
can
for the
see the
best.
exponential graphs
Hmm.
rising.
Yeah,
Yeah.
yeah. Yeah. Can't help
How's
it.
in Canada?
Um, there are many cases actually, but how it's under control to some extent. But we do follow
Oh, that's
complete
good.
isolation, and we are taking a lot of precautions, and I hope that will work out.
Mm,
Yeah,
yeah, as long as people are all cooperating, so
that
that's
is
good.
true. Yeah, yeah. That everybody has to cooperate in this case, otherwise things won't
It's not
improve.
gonna.
Mm,
That's true. Yeah.
yeah. Okay,
So
great. So I looked into some of the questions which you had shared with me on binomial. They're all based on binomial theorem. So I thought we'll go through some basic concepts and build a base to solve those types of questions. And indirectly, I will provide solution to your questions, okay, with my examples. Will that work for you?
yeah, perfect.
Right.
Thank you.
And then you can solve your questions, share with me the solution. In case there is any difficulty, definitely I'll provide you the solution, okay? So let's
Yep.
begin with the lesson which I have prepared for you. And let me share the screen. So as I was saying, we'll talk about binomial theorem today. We'll learn the concepts and take up some examples. So you are well aware of binomial theorem, which is basically when we say binomial, we are talking about two terms, right? A and B are the two terms. Expansion of nth power, where n is a natural number. You can say a whole number because 0 also is included. A plus b to the power of n can be written as a series, sum of some terms, where each term is qualified with a binomial coefficient, which we say NCR, or written like this, or in many different ways. I'll use different conventions. NCR is another convention which we use, and of course, this one is always there. So the powers are a to the power of n minus r times b to the power of r. We'll see the properties of these powers and how they are related. So we'll basically focus on how do we expand such terms. We'll also see their correlation with Pascal's triangle. We'll see how do we multiply them. We'll look into some patterns of binomials. We'll explore this notation further and also calculate some approximate values using binomial theorem, prove divisibility, and have some examples which could be very useful from examination point of view. Now, once again, this particular expansion which I have given you in short form, basically we say sigma notation can be expanded and written as shown here. A plus b to the power of n is nc0 a to the power of n plus nc1 a to the power of n minus 1b and so on. The last term being ncn b to the power of n. Now, this NCR, which I'm reading, this should be read as NCR or N choose R. A very important term here is N choose R, since when we look into many counting principles, you will see that there are so many cases when we have to like choose numbers. Let's say we want to choose a committee of 5 members out of, let's say, 25. How many combinations can be there? So these two terms come from there actually, combination C and choose, right, C. So it makes sense. And choose R.
Right.
Choosing 5 out of 25. That is what it means. And the direct answer is n factorial over n minus r factorial times r factorial. Now let's also understand what is this factorial notation, right? N factorial really means product of natural numbers from 1 to n. We could write this as n times n minus 1 times n minus 2 times n minus 3 till 1. Correct? So that
Mhm.
product of n terms, 1 to n, is n factorial. So that gives you basics. Now, let us take a few examples and see how they are also related with Pascal's triangle. So you did Pascal's triangle where you start with 1 and then diagonally we go 1 and then in the center we basically add the above two numbers to get the middle number, correct? So that is how we expand, correct?
Mhm.
So we get these terms in the Pascal's triangle. Pascal's triangle can help expand binomial expressions. Now, these terms which you see in between, they act as coefficients. For example, let's take a plus b to the power of 0. You know, anything to the power of 0 is always 1, right? So that is just 1.
Right.
And that you get from this particular 1. Now, a plus b to the power of 1 means a plus b, right? The same term. So you can write this as
Yeah.
a plus b. And this a plus b matches with the, we call that as the zeroth row. This is called the first row. So in the first row of Pascal's triangle, we have two coefficients, 1 and 1. These are the coefficients of a and b, as you can see. You'll appreciate it further as we go down. A plus b whole square, you know, is a square plus 2ab plus b square. The coefficients are 1, 2, and 1, correct? You can see 1, 2, and
Mhm.
1 as the coefficient in the second row of the Pascal's triangle. Similarly, a plus b whole cube, the coefficients are 1, 3, 3, and 1. Now, 1, 3, 3, and 1 are the coefficients in the third row of the Pascal's triangle, and that tells you that, well, you can follow this pattern and you can expand any power using the Pascal's triangle. The numbers in the Pascal's triangle become the coefficients of the expansion. So if I have a plus b to the power of 4, I know the coefficient should be 1, 4, 6, 4, and 1. And definitely, when the power is 4, there will be how many terms? There will be 5 terms, right? One more than the power.
Right.
The 5 terms are with coefficient of 1, 4, 6, 4, 1. Correct? So that is how you can easily expand using the Pascal's triangle. Now, you know, in Pascal's triangle, there are all kinds of symmetries. The terms on the left and the terms on the right, they match up. So those kinds of symmetries will also be there in binomial expansion, correct? So that is how it is. So you can expand and verify whether a plus b to the power of 4 is exactly what we wrote here from Pascal's triangle or not, correct? By multiplying a plus b whole cube with a plus b, which I've did all this exercise, combining the terms, we definitely get the same answer. So it could be verified like this. Okay, as an example, you can always take a plus b to the power of 5, use the fifth row of the Pascal's triangle, write down the coefficients, and you know the a and b terms, their powers should add up to 5. That is another important thing, correct? So
Right.
we looked into many patterns. It's a good time to just summarize them together at one place. So in this video, here in this part of the video, we'll summarize all our learnings, which forms the base or the foundation for binomial theorem and related examples. So we know a plus b to the power of n in sigma notation is NCR a n minus r b to the power of r. This is also called the general term, correct? So that is the general term for any binomial expansion. So when you write in expanded form, it is as shown here. Now, few observations which we can make is, what is the degree of polynomial? Well, whenever you expand binomials, then the degree of the polynomial is n, the same as the exponent of a plus b. Number of terms, we saw that number of terms are one more than the degree of polynomial. What is the sum of exponents of each term? So exponents, if you add, that means n minus r plus r. What is n minus r plus r? Definitely, it is equal to n.
And
So, sum of the exponents is always n. Clear?
right.
We also
Yeah.
notice that the coefficients equidistance from beginning and end are equal. That is the symmetry we talked about. And we also saw that symmetry in the Pascal's triangle. All expansions show decreasing power of a. As you can see, a power is n, n minus 1, n minus 2, and so on. Decreasing power of a and increasing power of b. Power of b is 0 here, 1, 2, and so on. and their sum will always be n. Symmetry. The coefficients same distance away from two ends are exactly same. They are equal. The coefficients are exactly the numbers in the Pascal's triangle. So there is one-to-one correspondence between the binomial coefficients and the Pascal's triangle. And that is how you can connect both these units. Okay. Let's take up an example.
Yeah.
In this example, you need to expand a minus b to the power of 6. So can you do that?
Yeah. We
Okay, great.
just use Pascal's triangle and
For
then
now,
take the
correct.
coefficients.
Perfect. Since using NCR, you're not very familiar with. So you have to go back to the Pascal's triangle, make all the rows, and then look into the sixth row. You know, the sixth row coefficients will be 1, 6, 15, 20, 15, 6, and 1. You can put those, and then the coefficients of A will decrease from 6, 5, 4, 3, 2, 1, and 0, and the coefficients of B will increase from 0, 1, 2, 3, 4, 5, and 6. So you get all the numbers. However, we had a negative term in between, correct? So this negative means
Yeah.
associate this negative with b. So if b power is even, negative becomes positive. If b power is
Positive.
odd, it is negative. And therefore, you expect alternate negative terms. Do you see that? That is mainly because we have minus b there. So all odd powers of b will result into negative terms. You will notice that these are the terms. This is which term? This is the second term. Do you see that? This is the second term. This is the fourth term with negative coefficient. This is the sixth term. So even number of terms will have negative coefficient in case of
Right.
a minus b. It's a good thing to remember, right? So now that gives you kind of a hint that if I have a plus b and a minus b to the same power, and if you want to add them up, then the even number of terms will cancel out and you'll get
Yeah.
twice the odd number of terms. And if you want to subtract them,
Mhm.
in that case, the even number of terms will double up and the odd number of terms will cancel out. So there could be many questions
Cancel.
based on the combination of this even and odd terms. We'll look into those examples also. And we have a very interesting example where we are going to look into square of even and odd terms also. Correct. So I think we have a good foundation. Did you understand all this so far, Amy?
Yes, I did.
Okay, great. So now let's try to evaluate the general term so that we are in a good position to calculate what is NCR. Do you understand? NCR is what? So I'm writing big and bold. NCR, if I have to calculate, it is given by the formula n factorial over n minus r factorial times r factorial. That is the formula which I've mentioned here. Now, we'll just take up an example and show you how easy it is to calculate the coefficient. You don't really have to go back to Pascal's triangle. Let's take an example and evaluate the value of 11C4. Now, 11C4, when we use the formula, 11 factorial in the numerator, then in the denominator, 11 minus 4 factorial times 4 factorial. Now, 11 factorial really means what? 11 times 10 times 9 times 8 times 6 times 5 times 4 times 3 times 2 times 1. That is what 11 factorial is. And 11 minus 4, that is 7 factorial, are numbers 1 to 7 multiplied. And 4 factorial is the numbers from 4, 3 to 1 product, correct? Clearly, we can cancel some of these terms, right? So when we cancel 11 over
7.
all this, what we are left with 11, 10, 9, 4. Since 7 factorial, do you see this? Cancel away.
Gets cancelled.
So we are left with, when we have 11C4, we have 4 terms. You can say 4 numbers. I should not use terms, but we can see 4 numbers in the numerator and 4 numbers in denominator. However, the difference is one is in decreasing order, right? One is 11, 10, 9, 8. And the other one is 1, 2, 3, 4. Done. That is how you calculate very easily 11C4. you don't have to really worry about this formula. You get the idea?
Mm. Yeah.
So if I want to calculate, let us say 25C3, that means it is 25 times 24 times 23 in the numerator and 123 in the denominator. Simple as that. Three terms, starting with 25, 3 down, and starting with 1, 3 up. That's how you calculate NCR. Is that clear?
Yeah.
Now let's further look into these notations. Just a summary for what we have learned so far. So sigma notation is this sigma notation, correct? So we are going to use sigma notation to expand a plus b to the power of n. As I said, the general term is written here, ncr, a to the power of n minus r, b to the power of r. It really means we are going to substitute the value of r from 0 to n and add the terms one by one. The value of r is between 0 to n, and then we are going to n. Add them up. NCR is called the coefficient in the expansion, correct? And the way to calculate NCR is n factorial divided by n minus r factorial times r factorial. Perfect. And the factorial notation is n factorial is equals to n into n minus 1 into n minus 2 and so on till 1. So that is what it is. Relating with the Pascal's triangle, NCR is directly equal to T and R, where T and R is the term number in Pascal's triangle, correct? So
Mhm.
T and R is the value of rth element and nth row of the Pascal's triangle, correct? Similarly, the coefficient of this corresponds to n plus 1th row in the Pascal's triangle. N plus 1th because the first row in the Pascal's triangle is the 0th row, right? So then n plus 1th row. So that is kind of link of whatever we learned so far. Now, let's take up some examples. And this is kind of a practice exercise for us. We'll quickly go through it. So, Amy, can you please read example number 5?
Yes. Find the coefficient of each of the following in the given binomial expansion.
Mm-hmm.
A to the power of 4, b to the power of 8 in a plus b to the power of 12.
Correct. So to find the coefficients of this, it is kind of important to understand that n is 12 and r is the power of b. So we get 8. So 12C8 is the coefficient of a to the power of 4, b to the power of 8 in the expansion given to us. Is that clear to you?
Yeah.
Okay, because see, when you expand a plus b to the power of n, you get nc0 a to the power of n. So b is 0, right? B power. nc1
Mm-hmm.
a n minus 1 b to the power of 1. So you can now match r value with the power of b. R ncr b to the power of r, correct? So that is the link. And
Mm-hmm.
therefore, we could see 12 is the power B8. And now you know how to calculate 12C8. You have to write 8 terms in the numerator, 12, 11, 10, 9, 8, 7, 6, 5. Those are the 8 terms. And 1 to 8 in the denominator. Just multiply and simplify to get your answer. So we get our answer. You can use calculator as shown here, correct? So that is a simple way. Second, we have taken the second example, p to the power of 5 in 1 minus p to the power of 11. Now, when we talk about p to the power of 5, that means we have odd power of minus p. Odd power of minus p will result into a negative term. So in this case, the
Mm-hmm.
answer will be negative. So I should have written here negative 462. So this is minus 462. Correct. The C is x to the power of 4 y 12, but within the brackets, you will see I didn't use a simple term like a plus or minus b. I'm taking 2x minus y. So a in this case is 2x and b is minus y. It's kind of combination of the previous. So minus y to the power of 12 will make it positive. So we do expect a positive answer as shown here. However, the first term is 2x to the power of 4, so we have to have 2 to the power of 4 also, which is very important. It should not be neglected. And then multiplied by 16C12 to give you the complete coefficient of x to the power of 4, y to the power of 12 in the given expansion. Is that clear to you?
Yeah.
Okay, so let's move on and take us some more examples. In this case, what I've done here is I've used again the Pascal's triangle just to connect. But in the example, I'm taking a reciprocal term, x and 1 over x. Clearly, when you multiply x and 1 over x, sometimes they can get cancelled. So we may have terms which are independent of x, correct? We may have terms which have
Mhm.
negative powers of x. Now, in this particular case, since the power of 5 is there, we have all the terms with x powers. None of them is independent of x. However, if this was even, then some of the values could have cancelled, correct? So we
Mhm.
just expanded this using the fifth row of Pascal's triangle and just rewrote and simplified our expansion, getting the result, right? You could also expand this using binomial theorem and its coefficients formula, which we've learned, correct? Let's move on and take up another example. This time in the example, we are taking a radical square root, right? So we took a reciprocal function. We took some powers also earlier. Now we are taking radical. Just to give you a flavor of different types of terms which could be there in the expansion and which are commonly seen in any test paper. Since the power is 4, we are going to look into the fourth row of Pascal's triangle, the coefficients being 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. Powers of A decreases 4, 3, 2, 1, 0. Powers of B increases from 0, 1, 2, 3, 4. And A and B are the values as square root x and B is minus 2 over square root x. Substituting those two values, which I've done in this part, so A is square root x and B is minus 2 over square root x. Just substitute, expand, and simplify to get the result. So we get a result as shown here over then. So these are the steps to be followed, correct? So simple algebra
Mhm.
here helps you to get the result. Now, in these types of questions, you will now notice that we do have a term which is independent of x. You get the idea? 24. This is kind of a
Yeah.
reciprocal multiple, is independent of x since the power is even. So when the power is even and you have this kind of an arrangement, you do get terms which are independent of x, right? They're constants. For example, 24 in this particular case. In the previous case, the power was odd. We did not get any term which was independent of x, correct? Okay.
Wait, so are you saying only if the power is even, you get a term that's independent of x if it's in this form?
Yes, yes, that is what I'm trying to say.
Oh, okay.
Otherwise,
But
we
just a
would not.
quick thing, can you find that the coefficient of that term that's independent of x without doing this whole process? Like what happened if it was to the power of like
Yes, we
15?
yeah, we can.
You're not
So
going to write
what we
out
will do is
everything.
we know
Okay.
that the general term will be NCR, correct? NCR,
Yeah.
a to the power of n minus r and b to the power of r, right? This general term is actually term number tr plus 1 because nc0 is the first term, correct? Now, if you want independent of x, that means when you
Hmm.
multiply these two terms, the exponent for x should be 0, right? So we'll take up an example in that
Yeah.
particular.
Yeah.
The exponent of n should
Because
be
x to
0.
the power of 0
Correct. So in this
is 1.
particular
Yeah.
case, what you are going to do is you really don't know what is NCR, but you know that a is square root of x. So you can say x to the power of half, that is square root of x, a, right? And
Yeah.
power is n minus r times we have minus 2 over x. This x is like power of minus half, correct?
Yeah.
Minus half times r, correct? Now from here, you can combine the x terms. So x power here is half into n minus r plus minus half into r and equate that to 0. You'll get the value of r and n. You can do that. So we'll take up an example to
Right.
show that. Is that clear? We'll take up an example.
Okay. Yeah.
So we'll have some example here. Let's move on. Now, here is a very beautiful example, and that is application of binomial theorem. You see, the question here is, can you please read this question, Amy?
Yeah. Find an approximate value of 0.99 to the power of 5 correct to 3 significant figures.
Right. So it is a very difficult calculation as such. But 0.99 can be written as 1 minus something, correct? That makes it a binomial.
Right. Yeah.
And now we can expand it as a binomial, correct? And easily find the coefficient. So that is the whole idea. So 0.9 into the power of 5 can be written as 1 minus 0.01. It's very easy to find powers of 1 and 0.01, correct? So now we have a
Right.
binomial expansion. I can always expand 1 minus 0.01 is 1 over 100th term, right? 1 over 100th term. So we'll
Yeah.
expand. 5 means the coefficient should be 1, 5, 10, 10, 5, 1. We took these coefficients from Pascal's triangle. Since you're not so familiar with the coefficients as such, NCR, we just write this. So the terms will be, first term, coefficient is 1. Second coefficient is 5, 10, 10, 5, 1. So these are my 6 coefficients for the expansion of 1 minus 0.01. Minus means alternate terms will be negative. You see the alternate terms being negative, right? So with all those
Yeah.
powers of negative, they will be negative. And 1 over 100, correct? So when you do this expansion, this is what you get. Now, you will realize that those terms which are 1 over 100 to the power of 5 and 1 over 100 to the power of 4, these are very small values, correct? So we could neglect it.
Yeah.
Because we are interested in 3
All right.
significant figures.
Yeah.
So you can take the first 3 terms or 4 terms, I should say, and that should give you accurate answer, right? So neglect the 5th and 6th
All right.
term. So that is 1. 5 divided by 100 is 0.01. 10 divided by 10,000 is 0.001. And when you do this subtraction and addition, you get 0.951. Such an easy calculation. You see this?
Yeah.
So it's very
So
easy
yeah,
to
so it's
calculate
about like
powers.
looking at the number,
Yeah,
yeah, and then using like values like 1 and 0.01, that stuff like that, which you can easily work with.
correct.
Yeah,
And
better than like 0.99 or something. Yeah.
correct. And significant figures is important. So if there are 3 significant figures, just take 4 terms. You'll get accurate answer to 3 significant figures. Is that clear?
All right. Yep.
Now let's take up even and odd terms in slightly more details, as most of the examples were related to even and odd terms. So we just touched upon it earlier also. But this time, can you please read this question now?
Yeah. If O be the sum of odd numbers and E be the sum of even terms, in the expansion of x plus a to the power of n, prove that A, O squared minus E squared equals x squared minus a squared to the power of n. And part B, 4OE equals x plus a to the power of 2n minus x minus a to the power of 2n.
Yeah, very complicated question. So what we have done here is we'll first understand what is odd and even term once again, and then jump into their squares. So as we saw earlier, x plus a to the power of n. So when you talk about plus a, we do get all the terms with positive numbers, as you can see, right? Now, if I do the similar expansion with minus, then we do get alternate negative terms, right? Alternate negative terms. Now, we would like to split this series into 2 odd and even terms. When we say odd and even terms, then we are saying odd 1357, term number 1357 is odd. What I'm saying is term number 1357. These are odd numbers, right? Odd. When I say even term numbers, then means term number 24601. Correct? So what you notice basically is that in the odd term numbers, the first term is with C0. Do you see that? C, NC0, NC2. So that series, we can call that as a series. Sum of these terms is always a series. So this series will treat this as an odd series. Plus, the other series, other half, alternate terms which are with odd, which are actually even terms with NCR R value being odd. We'll treat that as the even series. Is that clear to you?
Mhm.
So first
Yeah.
term, third term. So first term, third term, which is this, will go to the odd series for 1, 3, 5, 7. And the even number of terms, which is basically 2, 4, 6 with NC1, NC3, will go into the even series. So that is how we get these two series, odd and even series. That is the general way of considering these series. Correct? So you can clearly see we have two different series. Now, when we are talking about
Yeah.
x plus a to the power of n, everything is positive because this symbol here is positive, right? However, if we talk about x minus a to the power of n, we have the series of odd minus even because of that negative sign associated with the even terms.
Right.
And therefore, the expansion of x minus a to the power of n is basically odd terms minus even terms. Now, clearly, if I
Mhm.
add these two, what will happen? The even terms will cancel. You'll get twice the odd terms.
Yeah.
If I add, in that
Wait.
case, these will cancel, correct? And you get twice the
Oh,
odd terms.
yeah.
Correct? You get two odd
Right.
terms, right? Twice the odd term. However, if you subtract, odd terms will cancel and you get twice the even terms. Simple as that. Clear? Clear?
Right. Yeah.
So many questions are related with odd and even terms, and easily what you could do is you could split your series into the combination of, once again, odd and even terms. So let's say this is your one series, put all the odd terms together and even terms together. And then, if it is subtracting, in that case, the odd terms will cancel, you get twice the even terms. If you add them, even terms will cancel, get twice the odd term. Very simple. Okay. Now, what happens when you multiply them? That is what we are going to look into in this particular example. So we have already known what happens when you add and subtract. Now let's see, multiplying equation 1 and 2. When I say equation 1 and equation 2, I really mean when I'm writing this series as combination of odd and even, right? So clearly, you can say O plus E times O minus E is O square minus E square. That's what I meant when I wrote O square minus E square right there. So when you multiply this series, O plus E times O minus E, we basically get what? Well, we have these two terms here on the left side. You're just multiplying this, correct? So x plus a to the power of n times x minus a to the power of n, which is x square minus a square to the power of n. So that is how we prove the question. Is that clear?
Hmm. Yeah.
So we have x plus a to the power of n times x minus a to the power of n. You could write this as x plus a, let me write this in bracket, times x minus a, everything to the power of n. And inside term, is x square minus a square, correct? To the power of n. Is that clear to you now?
Mhm.
So we have shown part A. Now, what is 4 times odd terms times even terms, right? So 4 times odd terms times even term basically means, when you expand a plus b whole square and a minus b whole square, the center term is 2ab. So when you do a
Yeah.
plus b whole square minus a minus b whole square, you get 2ab minus 2ab, that means 4ab, right? So that is what is 4 odd times even is.
Oh,
So when you do
okay.
that, this is what you get. And you can write this in simplified form as shown here. So 4 times odd and even terms when you multiply, you get x plus a to the power of 2n minus x minus a to the power of 2n. Is that clear to you?
Hmm.
Correct. So I'll actually upload this video. Then you can go through this once again and see all the calculations. But that relates to most of the questions when we talk about odd and even terms, right? Let's take example.
All right.
Example 12. We'll now explore odd and even terms. Here, the question is find a plus b to the power of 4 minus a minus b to the power of 4. Hence, evaluate. So we have taken some a and b values, which are radical values, square root 3 plus square root 2. And for, all right, these two values, and we will just calculate their values. Let us see how easy it is to do. Well, when you want to subtract, then your subtracting means the odd terms will cancel away. And what you're left with is 2 times the even terms. Even terms means second, fourth, sixth, and so on. Second term is NC1, NC3, likewise, correct? So we get those terms which will double up. So a plus b to the power of 4 minus a minus b to the power of 4 is 2 times the sum of these odd terms. Even terms, right? 4C1, this sum of these even terms, correct? So we have in this 5 numbers, out of these 5s, these are the terms which are to be included, right? The even terms. So when you add, when you just expand, you know what 4C1 is. 4C1 is just 4, and 4C3 is also 4. So you just expand it and take this common, you get your answer as 8ab, and within brackets a square plus b square. So that is the first part, that is expand the term a plus b to the power of 4 minus a minus b to the power of 4. Now let us evaluate the value for this term. Basically, we'll now substitute a as square root of 3 and b as square root of 2. Once you substitute in this particular formula, which we just derived, right, you get 8, which was there, times a times b, a and b square root 3 times square root 2, and then inside the bracket, a square plus b square, and you get a value, which is 40 square root 6. So that becomes our answer. Sometimes we say the answer is a square root, let's say n, find a and n. So you can say, what is this? A is 40 and n is 6. That is how we actually design our questions. We say, well, this is equal to a square root n. Find a and n, right? So at the end, you can say, what is a and n? Correct? So that is how such questions are designed. Do you understand these steps, Annie?
Yeah, kind of. It's yeah, it was a little bit. I think, like you said, I need to re-watch it.
Definitely.
But
Definitely.
yeah, I think
Yes.
yeah.
Very important. So it's correct. So, Amy, as I was saying, since there are 5 terms and the even number of terms are second and fourth, so there are only 2 even terms, right? There are 5 terms. So 1, 2, 3, 4, and 5. Even number of terms are 2 and 4. They double up. So 2 and 4 double up. Therefore, we have these 2 terms, NC1 and NC3. And we add them and multiply by 2 to get our terms, right? So go through this, you will understand this concept. And then when you combine and simplify, this is what you get, right? Okay, let's take another example, this time with odd terms. So now what I've done is, I've taken a very similar example. The only difference is we have plus in between. So can you please read this question?
Find a plus b to the power of 6, add a minus b to the power of 6.
Correct.
Hence, evaluate root 2 plus 1 to the power of 6 plus root 2 minus 1 to the power of 6.
Perfect. Now we're talking about adding them up. In case of adding them up, then the first term, third term, fifth term will all add up and they become twice. The second, fourth, and sixth term, they will cancel away, correct? So this time in the series, we have odd alternate terms which will double up. So we have 2 times NC0, a to the power of n, NC2, a to the power, like this we have a series, correct? Now in this case, the power is 6. Since the power is 6, as we see here, it will be 2 times 6C0, 6C2, 6C4, and 6C6, which I could also write as 6C0, right? So those are the four terms which will add up, and twice these terms will be the sum of the given binomial expansion. Is that clear to you?
Yeah.
Right. So twice the odd number of terms. Now, we know what NC 6C0, 6C2, 6C4, and 6C0 are. Substituting these values, which is 115, 15, and 1, 2 times a to the power of 6, we get our expansion, which is right there before you. 2 times a to the power of 6 plus 15 times a to the power of 4 plus 15 times a square b4 plus b to the power of 6. Well, everything was multiplied by 2. So that becomes the general expansion for a plus b to the power of 6 plus a minus b to the power of 6. Now, you need to do what? Substitute a as square root of 2, b as 1, and see what do you get. So when you do the substitution, a as square root of 2 and b as 1, this is what you get, which is written there. And since these are even powers, those square root terms, you get the whole numbers. And when you add them up, you get a number, which is 198 in this particular case.
Mhm.
So, Amy, this is basically a two-step problem. The first step here is, whenever you're given something to expand, find a general term, right? So first step is to find general term.
All right.
And then substitute and evaluate. That is it. So based on this concept, try some questions from your book. And if there's any difficulty, we'll look
All right.
into that again. Okay, no problems.
Okay.
Now up to this place, is it all clear to you?
Yeah, but like you said, I'll just go visit a few
Yes, you need to.
again the video.
Sure.
Yeah.
Now here is a different kind of an example. We'll now talk about trinomials. So binomials we are looking into. So I've taken up an example. How do we expand trinomial using the binomial theorem? Well, you would combine the two terms, it becomes a binomial, right? If I say 1 plus x is one term and x squared is the other term, it becomes a binomial. So you could actually expand any polynomial using binomial expansion. And that is what is
All right.
focused on this particular example. So we'll expand a trinomial now, but it gives you a concept that you could expand any polynomial. Is that clear?
Mhm.
So the question is, use binomial theorem to expand 1 plus x squared whole cube. Now in this, what are we doing? We are combining two terms to make it a binomial. So let y be equals to x plus x squared. So instead of what I thought initially to combine y, we actually combine the other two, x and x squared. It is your choice. You could have done that also. But it is
All
better
right.
to keep one alone. This is better because we want to, power of 1 is 1, right? Do you see that? 1 to the power of 1 is
Mhm.
1. So it is good idea to keep one separate if you have a choice. So that is why we made
Right.
y as equal to x plus x squared. Now, since y is x plus x squared, we do get a binomial, which is now 1 plus y whole cube. So you have a binomial expansion.
Mhm.
Now, and when you expand, simplify in terms of y. But well, y is a binomial, right? So now do that expansion again, substituting the value of y.
Yeah,
So
that's
yeah,
clear.
yeah. So, but basically, you're using the binomial theorem twice since you clubbed two in one, and then simplify this to expand a trinomial using binomial. Is that clear to you?
Right. Yeah.
This is a very important question from test point of view. Normally, what they will do here is they will have they'll give you this equation, right? With, let us say, they will not write 6, but they will write P, and they will not write something like 7, they write Q, right? And they say, find the values of P and Q in this expansion. You get the idea.
All right. Yeah,
So
yeah.
those are the type of questions which you could have. They may change this to, let us say, square root of 2x, for example, and then tell you to find the value of P and Q, right? So in different
Yeah.
ways, this question can be asked. Very important from test point of view. Perfect. So let's move on and take another example. This is a short questions which are easy to answer, but many times in the test paper, we begin with these kinds of questions. Can you please read and answer this?
Yeah. In the expansion for x plus y to the power of 17, there is a term x to the power of k, y to the power of 9.
Correct.
Determine the value of k.
So what is the value of k?
Sorry, I think my internet is
Oh,
poor. Did
okay,
you
okay.
say something, sir?
What is the value
Oh,
of k? Can you just tell me in a second?
oh, yep. So, all right. So since we know n is 17 and
Correct.
we have r is 9, you
Correct.
can just find k by doing 17 minus 9,
That is so true. So easy,
which is
right?
8. Yeah.
Which is 8. Once
Yeah.
you know k is 8, the second question is determine the coefficient of this. That k is 8, right? Anyway, 17 we know, right? And we know 9. So the
Mhm.
coefficient will be 17C9, correct?
Yeah.
That is part 2. You can use a calculator. Calculator does have this function, combination formula, and then you can use this to find the value. So that is the best way to do it. Otherwise, you know the formula to use and then calculate. Okay. Now, let us take another examination type question, which I was actually talking about earlier. Can you please read this question, Amy?
In the expansion for 1 plus x to the power of n, the first three terms are 1 minus 18 plus 144.
Correct.
Determine the value of x and n.
Perfect. So we have 1 plus x to the power of n. Both you need to find what is x and what is n. And we have given you three terms, first three terms. Now, in this particular case, what you could do is you can have a general expansion for 1 plus x to the power of n, which is given here, right? So once you have this general
Yeah.
expansion, then you can correlate the terms, right? So the first term is 1, so 1 and 1 will match, not a problem. The second term is n times x, which will be related with minus 18. And the third term will be nc2 x squared, which will be related with 144. So with that, you actually get two unknowns and two equations. So nx is equals to minus 18, this second term, and the third term is nc2x squared, which is 144. You can actually isolate x from the first and then substitute in the second. In that case, you have one equation in just n, solve for n. So this is more or less exercise on solving the factorial related terms, right? So n factorial over n minus 2 factorial over 2 factorial times x squared is 144. NC2 is what this all is. Now we know x is 18 over n. We substituted x with 18 over n to get our equation only in terms of n. Now since there is only one unknown n, we can always find that value. So just expand and simplify. When you do so, follow some steps as shown here. You do get the solution, uh, follow these steps, the value of n comes out to be 9, correct? Now, these are very critical steps. When we say n factorial, n times n minus 2 times n minus 1 times n minus 2 factorial. See how we stopped here. Let me go back to this. So n factorial is n times n minus 1 times n minus 2. I stopped here since I know n minus 2 factorial is also in the denominator. So we can cancel after this.
Yeah.
We stopped here. In the denominator, we have n minus 2 factorial. So this n minus 2 factorial cancels with n minus 2 factorial. We're left with the third term, which is 2 factorial, which is 2 times 1, right? So in the numerator, we have now n times n minus 1, in the denominator 2, and of course we'll square 18 over n to get 324 over n squared, which is equals to 144. Now you just cross multiply, you get a quadratic equation to solve, right? And then solve your equation to find the value. Is that clear to you?
Yeah.
Well, one of these n gets
I
cancelled.
like that
So
question.
it is a linear equation, not even a quadratic equation to solve. So very simple
Yeah.
example. Sometimes you'll end up with quadratic equation, but here, n and n square, you are left with a linear equation to solve. N is 9. Once you get 9 as n value, you can always find the value of x. Do you understand this type of example, Amy?
Yeah, that's really clear.
Okay, great. So with this, we'll actually end our video today. I'd like you to practice some questions which are based on what we have talked about. In case there is a difficulty, share with me. And from there, we'll take up those examples and move forward. So
All right.
can you summarize, Amy,
That was
what
a
did you
great
learn
lesson,
today?
sir. Yes. So we started off with just the basics about binomials and like Pascal's triangle, the different patterns within it. There are more videos on like the different patterns with the triangle on your channel, but we just went over the quick basics with the rows and things. Then, yeah, so knowing that Pascal's triangle has the coefficients for the expansions. Then we went into more, yeah, so this page I would recommend like printing off and kind of just keeping up there because it's given an overall summary of this topic as a whole. So yeah, that's a really good page. I think it's completely like given like broken down to a really simple way to understand it. So I don't think I really need to explain in any more detail that
Yeah.
page. Yeah, it's done really well. And then the rest of the lesson, we just went over these different kind of trickier questions that you would see in exam thing. I think, yeah, so we went over reciprocals, radicals. They were just questions where same principles apply. It's just that it's using square roots and stuff like that, which are a little bit harder. So, but that's the same concept. So that's all right. It was the even and odd terms I felt was the hardest out of like today's lesson because this is like kind of brand new. But again, there is just a process. This is like a 3-step process, what you said. So you said find the general term, first of all, and then you substitute the value that you get into the general term, and then you just evaluate it by expanding it and simplifying. And with those concepts, you can just use the radicals and things like that. So it's just a 3-step process.
That is so true.
After that, we talked about trinomial expansion. Really simple, you just kind of group them. And if you have the option of putting one as a side as one like A,
Good
and then
point.
another one as B, do that because you don't want to mix the 1 and the X when one can be easily, because anything to the power of 1 will just be 1. So you want to keep that as a separate thing. And yeah, the rest of it was quite easy after that. So yeah.
Perfect. So with that, we end our today's lesson. There are many videos, as you said, related to this. Follow some of the videos. Wherever you feel difficulty, write your comments. I normally respond to the comments very fast. And then from here, we'll move forward. So it was nice,
All right.
discussing all this with you. And I hope you get all the concepts.
I did. Thank you so much, sir, for
Okay,
taking
then.
the
Thanks
time
a
to
lot.
teach me.
Thank you. Have a great day.
All right. You too,
Okay,
sir.
so
Bye.
bye. So now, Amy, let's
Oh,
continue with your questions which you had. So tell me,
I
did
keep
you see
thinking I
the
need to end
solution
it
which I
and come
sent you?
back. Yeah, see, about that,